Hi, I'm Pallav from Just Tutors, and today we will learn about soaps and detergents. We will learn about their action, how does they work, soap and detergent, what is the cleansing action, and is there any difference between the action of soap and detergent? There is one more term, micelle. Well, this is the structure which is formed during the cleansing action of soap and detergents. So we will learn about these topics. Before we move further, I want you to try these questions, so you can pause the video, try these, then we will move on after checking these. Well, these are the answers of given questions. I hope you got the correct answers. Now let's move on. So first is soap. We all have seen that soaps and detergents are used for washing clothes. So obviously these are the cleansing agent. Now how these are formed? Well, if we talk about the soap molecule, it has two parts. One part is hydrophobic tail and the other part is hydrophilic head. This hydrophilic head has the ion, this is the ionic part, and this has the long carbon chain, the tail part. So we have one example, or we can say that the soap has one or more salts or fatty acids. So one example is sodium stearate. And detergents are the ammonium sulfonate salt of long chain carboxylic acids. We will discuss about these things in detail. Let's move on. So soaps. Well, as we discussed, soap molecule has two parts. One is the ionic and the other one is the carbon chain. They all have different properties. Due to their different property, cleansing action take place. So what happens actually, the ionic part, it is the polar end which mixes with water, but the second part, this is the non-polar end, and it mixes with fat. When we say fat, normally most of the impurities are oil based, like we have any dirt or grease or oil. So these impurities, so non-polar and the carbon chain mixes with the oil, dirt and grease, but the polar end mixes with water. So what happens actually, the ionic end dissolves in water, but the carbon chain dissolves in dirt. So ionic end try to push towards water, and in this a structure is formed called micelle. So let's see how is it. So we have this structure of micelle. You can see this is the dirt particle, this is the polar end, and this is the long carbon chain. So this long carbon chain is attached to the dirt, but this polar end wants to go into the water. It is trying to dissolve in the water. So this shape is created, which is called micelle. And these parts try to take this dirt away and they get success. So this is one more picture. You can see this is the long carbon chain, one part which is a hydrophobic, and this is the ionic part which is hydrophilic. Let's move on. We have action of soap here. So you can see this is the cloth, and this we have a dirt particle. It may be oil particle or grease particle. So you can see the long chain is attached to the dirt or the oil, but the ionic part wants to get dissolved in water. So slowly these chains are attached to the dirt particle, and these are trying to get dissolved, the ionic part trying to get dissolved in water. So this is the action of soap, and you can see at the end this is detached, this oil part is detached from the cloth. So the structure which is formed is called micelle. So this is all about action of soap. But soap has some limitations. It doesn't work well in the hard water. So for that we need something else which is called detergent. And before that we used two terms, hydrophobic and hydrophilic. Hydrophilic, which loves water, which wants to dissolve in water, and hydrophobic, which doesn't want to dissolve in water, which is insoluble in water. So the chain is hydrophobic and this ionic end is hydrophilic. So now let's discuss about detergent. So if soap is used in the hard water, what happens? The soap first reacts with the magnesium ion or calcium ion present in the water, so more soap is waste. And then these calcium and magnesium ion sticks with the cloth, and these harm the cloth. So it's better to have something else which is called detergent. These are the ammonium sulfonates salts of long carbon chain. They can work well in the hard water. The action is same. They have capability to dissolve in the hard water. So they work well. The charge and eliminates the formation of precipitate, which was in case of soap. Like if you use soap, then there would be a precipitate, but in case of detergent, it doesn't happen, and hence they are effective in hard water. Well, these are used in making shampoos and other cleaning product. Now let's move on. So now we have some questions. You can pause the video and try these again, then we'll move on. Well, these are the answers of given questions. Now let's move on. So thanks for watching this video. For more, you can visit justtutors.com. Thank you.